Welcome back to the classroom. My name is Mr. Wong. Today we'll be covering Module 2, Inquiry Question 2, or at least some components of it, with this exam question here from the 2018 Independent Physics question of 16. So let's have a look. We have a velocity time graph of a 4 kilogram object, as shown below here. We can note that in terms of velocity, this is going towards the east. And so we can conclude at the end of this, we've gone to this direction east overall. We have time as the x-axis, so let's look at what the question's wanting us to do. What was the final displacement of the object? Okay, so the final displacement of the object is going to be the area underneath our line here. So this area is equal to displacement. Now for those of you wondering why exactly is the area the displacement here, think about what's happening here. In order to find the area of this particular component, it is, or at least an area of a triangle, is half times height times width. Now the height that we have, which is our y-axis, is the velocity times time. If you look at the original equation from before of velocity is the change in displacement over change in time. So the change in displacement would equal to velocity times change in time. And just so happens that that matches the area of this graph. Okay, so that's why we're going to use the area calculation. So we know in terms of area it's going to be half times the height, it gets up to 15, times the width, which is 10. Plug it into your calculator, see what we can get. Okay, so we have an overall displacement of 75 meters. Now don't forget, I originally stated that the object is going towards the east and the line keeps going in that direction. So it's going to be 75 meters east. And that's how you do the first question here. The second question, it says, what constant force was acting on the object as it traveled? Now, why do we know it's a constant force? You can see here there is a change in velocity. So if there's a change in velocity, there must be some form of acceleration. If an object is accelerating according to Newton's second law of motion, there must have been a net force applied in order for it to accelerate in that particular direction. So and I'll do this in a different color, the gradient is going to be the indicator for us what our acceleration is, and from there we can work out the force. The reason why the gradient is going to be the acceleration, remember gradient is rise over run. The thing that's on the top is the velocity, the thing at the bottom is the changing time. So we have changing velocity over changing time. That's the exact same definition as saying acceleration. Acceleration is how much change in your velocity is there over a certain period of time. Okay? So, acceleration is going to be, and using the components, we have 0, 0 here, 0, 0, 0, 0, and we have 15, we have 10 and 15. Okay, so knowing our gradient formula, y2 minus y1, x2 minus x1, so we have y2 as 15, y1 as 0, and then x is 10. Plug it into your calculator, find the overall acceleration. Will just be 15 over 10, okay? That means it's 1.5 meters per second squared east. Then we plug it into Newton's second law of motion's formula. The mass, if you recall, I stated at the start, is 4 kilograms. So it's 4 times 1.5, and that'll give us an answer of net force of 6 newtons east. And that's how you do the question. So hopefully that gives you an understanding of how to interpret motion time graphs, and then how you can use those to work out also the net force of a moving object. Hopefully you enjoyed this video, give it a like for support and more videos to come in the future.